Textbook page number 12, solved examples. Question number 1. In question number, an iron ball of mass 3 kilogram. Let this is an iron ball. Mass of iron ball is 3 kilogram. And it is released from the height. This ball is kept on the height of 125 meters and fall freely on the ground. This is the ground, and this ball is allowed to fall down. Right? Assuming that value of G at this place, value of G is 10 meter per second square. We have to calculate three things. First, number 1, we have to calculate time taken by ball, time taken by ball to reach the ground. The ground. Second thing, we have to calculate velocity of the ball on reaching the ground. Velocity of ball on reaching the ground. And the third thing is asked, the height of the ball, the height of the ball at half a time, at half a time it takes to reach the ground. It takes to reach the ground. This third question means, suppose the ball takes from here to here to reach this, it takes time t. Then in the half time, means t upon 2 time, how much distance it is covering, that we have to take out. Distance means here, height we have to find out. So these three things are given. Three things are asked, and given are also three things. Mass of ball 3 kilogram. Height from where it is falling is 125 meters. And value of acceleration due to gravity is 10 meter per second square. So here we will use Newton's law of motion, the three formulae which we discussed previously, and we will calculate the values. We will calculate the asked things. So let us go to calculate the first question's answer, and here we have to calculate time taken by the ball to reach the ground. So which expression we will use here? We have mass. Mass is not useful for finding out first. Height and acceleration we have, right? In the first question we have to take out time. So for taking out time, which formula? Three formulae we have. First formula is what? Out of three expressions of Newton, V is equal to U plus AT. Then the second is S is equal to UT plus 1/2 AT square. And third is V square is equal to U square plus 2AS. So first question, time. So for time, all the first and second example, so let's turn to the first question. For that, we will use out of this three, one. Now third, in that t is not there, so we cannot use the third one. Now remain two things. Now first expression, in the first expression we have to calculate time. Velocity is not given, right? So we will not use the expression also. We will use the second equation of motion for calculating. We will use second equation of Newton's for calculating time. So by Newton's second equation. What is Newton's second equation? S is equal to ut plus 1 upon 2 at square. Let us substitute the values. Here S means distance. How much distance ball is? At 125 meters. So S is equal to 125. Initial velocity is 0. Time we do not know. Plus 1 upon 2. Acceleration we have to take here 10 multiplied by 10 and t square. T we have to find out. This will become 0. So 125 equal to 2 ones are 2, 2 5s are 10. So 5t square. We have to calculate value of t. 5 we will transpose here. 125 divided by 5 equal to t square. 1s are and 25 5s are 125. So 25 equal to t square. We need to find out t. So we will take out square root. So time is equal to 5 seconds. So time taken by the ball to reach the ground is 5 seconds. Is it clear? Now we will go to the next second question. In the second question they asked velocity of ball on reaching the ground. So here which one you will use? You can use any one, first or last. We will use a simple one. So V is equal to U plus A T. We have to calculate. Initial velocity is 0. Acceleration is acceleration is 10 meter per second square and time we calculated 5. So V is equal to 10 into 5, 50. 50 what? Meter per second, since it is velocity. This is the answer of the second question. So velocity of ball on reaching the ground is 50 meter per second. So in the third one, half time. T is equal to 5 upon 2, that is 2.5 seconds. And we have to find out height, that is S. So we will use Newton's second equation of motion. S is equal to ut plus 1 upon 2 at square. S we have to calculate. Value of u is 0 multiplied by t plus 1 upon 2. Value of a is 10 multiplied by 2.5 bracket square. 1s are 5s are. So S is equal to 5 into 6.25, right? So S is equal to 31.25 meters. This is the distance, right? How much ball fallen at half time? Means from here, this total distance is 4.0. Here, this distance is 125 meters, right? So ball comes at the half of time here, right? Height of the ball at half of the time we have to find out. This much ball is fallen down. We have to find out height of the ball from the ground. That how much is the height from the ground. So height of ball at half time, this much the ball is fallen down, right? We have to find out height of the ball at half time. That is 125 is equal to 125 minus 31.25 meters equal to 93.75 meters. Let's move to the question number 2. Is the first question clear? Let's go to the question number 2. Suppose from this ground surface a tennis ball is thrown up. Right? It is thrown up and it reaches at the particular height, and this height is 4.05 meters. Before coming down, means at this place its velocity becomes 0. On reaching at this height, velocity becomes 0, and then it starts to fall down back on the ground. Before falling down, it reaches to the height 4.05 meter. What was its initial velocity? Means we have to calculate how much is its initial velocity. Here for this is initial velocity, means how much initial velocity we will apply, so it will reach at this height, and then its velocity, final velocity, will become 0. And then this is the first question, and the second question they asked, what was over and how much total time will it take to come down. And then after this, when this, for this case, this is final velocity, this is initial velocity. This is for first example. And for the second question which is asked in the second example is, we have to take out time. Now for this time, here this will be initial velocity. Here you will be 0. Are you getting me? You will be 0. And we have to take out time. And in both the cases, we have to consider value of g is 10 meter per second square. Here also g you have to take 10 meter per second square. So let's go for the first case. For upward motion of the ball, final velocity for first one, final velocity, that is v, is equal to 0. And distance traveled is 4.05 meters. And acceleration, that is g, gravitation is pulling it up, gravitation is pulling it down, and object is going up. So value of g will be negative here, right? It is what? Negative 10 meter per second square. This is meter per second. Now by third equation of motion, v square is equal to u square plus 2as. Final velocity is 0. 0 square is equal to u square, we have to calculate, plus 2. Gravitation is negative 10. Remember, this negative sign is not for anything else. It is for the direction. It is for the direction. And multiplied by distance 4.05. So 0 is equal to u square plus 2 into 10, 20, multiplied by 4.05. This negative sign is for direction. So we have to calculate u square. This both we will, 0 is equal to u square plus 20 into 4.0. This one decimal point will move there. 2 5s are 10. Carry this 0 will keep. 2 5s are 10. Carry 1. 10. And 4 2s are 8. Decimal place at 2 places, means here. Means 0 we will write down 81.00. This value will be negative. Positive into negative, negative. We have to find out the value of u square. This we will say here. So u square is equal to only 81. This will get transposition. Negative 81 will become positive 81. We need to calculate value of u, not u square. So we will find out square root. So u is equal to 9 watt meter per second. So what was the initial velocity? If you will throw the ball 9 meter per second, then only it will reach the height 4.05 meters. Is it clear? Now, second example. Now let us consider the ball after reaching here, its velocity becomes 0. For the second question, when ball reaches up to certain height, its velocity becomes 0. Means here initial velocity for the second question is 0. Now suppose it takes time t. Time we have to calculate to come down. Right? Distance traveled by the ball. How much it will go up? That much only it will come down. So here also, how much will be the displacement or distance it will travel? 4.05 meters. So here also distance is 4.05 meters. Right? And velocity and acceleration are same in the direction. So here value of acceleration, that is g, is not negative. It is positive 10 meter per second square. So we have to use here second equation of motion. And by second equation of motion, S is equal to ut plus 1 upon 2 at square. So S is equal to 0 into t plus 1 upon 2. Value of A is 10. Multiplied by t we don't know. 2 1s are 2, 2 10s are, 2 5s are 10. Value of S is 4, here only we'll write 4.05. Now 4.05 is equal to 5t square. So we have to find out the value of t. 5 will transpose. So 4.05 upon 5. It is divisible by 5. Right? 0. Decimal point. 4 8s are 40 and 4 1s. 0.81. We have to find out value of t. So we will take out square root. So t is equal to, value of t is equal to square root of 0.81, 9. 0.9, not 9, 0.9. It is time, so seconds. Is this clear? Second example. Do you understand the second example? Textbook, page number 12. Use your brain power. Question is given here. According to Newton's law of gravitation, Earth's gravitational force is higher on an object of larger mass. Right? As the mass of object is more, that much force will be applied more. Are you agree? If suppose this is the Earth, and Earth is pulling one object whose mass is 100 kilogram and the another object whose mass is 10 kilogram. So according to Newton's law of gravitation, Earth's gravitational force is more on object of, here more force we have to, Earth have to apply, while here force required is less. Here force required is more. Yes, by Newton's law of gravitation. Force is directly proportional to the mass. We know the force is directly proportional to the mass of object. Means more mass, more force. Less mass, less force. Isn't it or not? If it is so, then why does not the object fall down with higher velocity as compared to object with lower with means it means that when object is falling down, both the object are falling down. So why they are falling at the same time in the free fall condition? Why velocity of this and velocity of this are not different? We have seen that during free fall, during true free fall, when there is no other friction, to free fall, both will reach ground at same time, right? Why they both are reaching the same time? This have to come first and this have to come later on, but this is not happening, isn't it or not? This is not during free fall, both are reaching same time. According to Newton's law of gravitation, heavy have to come fast and less heavy have to come, the object with more mass have to come first and object with less mass have to come later on. This is not happening. What is the reason? So this is so because acceleration due to gravity depends on mass and radius of an earth or the planet on which that objects are. This is the first reason. Then the second reason, the very much important reason, G. First reason. Second reason, because G, that is acceleration due to gravity, is independent of mass of falling object. And third reason for this question is acceleration means value of G at particular position, acceleration due to gravity at particular position or particular point is same for every object. It means if at this place on earth, if you will keep one elephant and if you will keep one small bird, kiwi, so both will experience acceleration due to gravity 9.77 meter per second square only. For elephant also it is same and for kiwi also it is same. Means acceleration due to gravity at particular point. If they are here, then on both. If they are here, then on both. If they are here, then on both. At the particular point, acceleration due to gravity is same. And due to that, the two objects are falling simultaneously during the free fall. Am I clear? Let us study well. In the next period, we will discuss about gravitational potential energy. If any doubt you